Welcome everybody to this weekly appointment with the CMCC webinar. Today we're going to have the last episode for this year of the CLARA project webinar series. CLARA is an H2020 project which aims at developing climate services for different sectors in our economic world. In particular, CLARA has developed 14 climate services. And today we have the pleasure to introduce the horizontal services that are the services that actually fit many different sectors. In particular, we're gonna present Data Clime and the Climate Data Factory, and we are having for Data Clime Giuliana Barbato. Giuliana Barbato is an electronic engineer who is working with us at CMCC since 2016, and she's an expert on post-processing tools for the analysis of several types of climate data. And on the other side, for Climate Data Factory, we have Harilaos Loukos. Harilaos is an entrepreneur with a scientific background, and his background is in oceanography. He took a PhD in Paris and then a postdoc at the University of Washington in Seattle. So before leaving the floor to them and to talk about the services that they have developed, I'd like to spend a few words about CMCC. CMCC is a research institution who was founded in 2005. Since 2015, we are a foundation which deals with the science behind climate variability and climate change. And so our mission is to provide reliable and timely scientific results which will in turn stimulate sustainable growth, protect the environment, and develop adaptation and mitigation policies in a changing climate. So we are organized in a network of different research institutes across Italy. I am based in Bologna at the Climate Simulation and Prediction Division, but we have offices at the Politecnico di Milano, at the Ca' Foscari University in Venice, at the University of Tuscia in Viterbo, at CIRA in Capua, at the University of Salento in Lecce, and at the University of Sassari. So we are structured in a research division. As I said, I am part of the Climate Simulation and Prediction Division here in Bologna, where we have like the Global Climate Modeling Group, and all the divisions deal with the interaction of climate with very different sector and parts of our society. The main topics of our research, as you can see, are modeling, policy, adaptation, and impacts on many sectors that are all linked to the climate science. We are very active also in the outreach, not only through peer-reviewed publication, but also with many events, out of which, of course, there's a series of webinars. We have like education program with PhD and master students, and you can find us on many social network platforms, and like we participate to many events to communicate our science to the rest of the world. So you can note that the webinar will be recorded and uploaded on the CMCC YouTube channel. You can see the video here, and like on the CLARA website, of course, and on the Facebook page, CLARA H2020. If you have any further question about the webinar, you can email webinar@cmcc.it. Just a second to introduce the forthcoming CMCC webinar of next Thursday, December 19th at 12:30, as usual, on urban flood modeling in a changing climate. The speaker will be Roberta Padulano from the REMI division at CMCC, and the moderator will be Mattia Madio from the RAS division, since always at CMCC. Last thing, if you want to take part in like in this webinar and ask questions to our presenters, please use the question tab on the GoToWebinar control panel to the right side of your screen. So I now leave the floor to Giuliana Barbato. Okay. Whenever you're ready, the floor is yours.
Thank you. Okay, good morning. I hope you hear me. And thank you, Stefano, for this introduction. And thank you, everybody, for attending to this CLARA webinar. So during this presentation, I will give you a general overview on Clime service developed by REMI division of CMCC Foundation. So what is a Clime service? Clime service is a tailored tool for processing of several high-resolution climate data that was born as a GIS plugin designed to support very expert users in climate analysis. Today, in the framework of CLARA project, the new release of Clime services has been designed as a interactive multi-user platform obtained by introducing new functionalities and additional climate data made available by different data providers. So, Clime service can be useful to evaluate different high-resolution climate data and climate data for different main goals that are to improve users with different skills and requirement, and to improve the understanding of climate impact through different climate solutions designed together users. So this platform can be useful for different type of users, for example, for policymakers, for private firms, for consultancy company, and for research. So we can see that the service, the goal is to provide a controlled application allowing users to carry out their climate analysis in autonomous ways. So the main features of these services are useful to support different users in their activity of climate change planning and implementation in different areas of interest, like agriculture, energy, water, and so on. One important aspect of this service is the ability to manage the whole information product chain from climate data storage, since their processing according to user requirements. Moreover, the processing of climate analysis performed by Clime service can include different bias correction techniques, climate analysis starting from multimodal approach, and more generally products to support different users for different impact studies like flood, drought, heat waves, and so on. It's important to stress that these functionality are continuous update in order to includes new functionality, new climate data, and new application according to requirements provided by different users, by different stakeholders for specific case studies. Summing up, the main features of this service are easy access to different climate data, customized climate analysis, and finally the possibility to have different output in different format to be easily readable by other software. So in this slide, the top picture on the right shows the outline of a Clime workflow. So concerning the input data of this service, Clime can provide different climate analysis currently starting from the high resolution climate data developed by CMCC over Italy, but also starting from climate analysis available in the framework of Eurocordex program, where the domain is Europe. Moreover, several climate variable, IPCC scenario, and several observational datasets are available, both gridded and or regional local station data. Concerning the products, Clime can allows evaluating different analysis. For example, Clime allows evaluating a set of different climate indices for precipitation, temperature, humidity, and it's important to stress that it is possible to integrate other indicators according to user requirement. For example, for a specific case that can be agriculture, energy, water, and so on. Concerning the output, Clime service is able to provide not only post-processing data like maps, shapefile, plots, but it also supports the end users, for example, for the development of the local climate profile. In this case, the results, the output of these services is a report. So this is an on-demand service. So how can Clime service support the end users? For example, the climate analysis performed by these services can be used for different impact study, for local climate profile of specific municipality or critical infrastructure, how processing and providing through these services the climate analysis on different spatial scale through high resolution climate data and up to very local scale, how through different climate indices for precipitation, temperature, humidity, and finally for different sector of interest. So this is a service is horizontal. Finally, this slide shows the web platform prototype of Clime service. And as mentioned before, the goal is to provide a controlled application allowing user to access your dedicated user area through the web platform dataclime.com, to select your tailored climate analysis by choosing step by step different parameters like input data, variables, area of interest, temporal scale, period, and other parameters. Finally, the user can download through your dedicated area different output as mentioned before. Briefly, in the framework of CLARA project, new functionality has been introduced in order to help end users, mainly consultancy company, in the risk assessment analysis in support of local authorities. In particular, in the CLARA project, the city of Barbato was chosen as a case study, and the goal is to provide through Clime service, through Clime analysis, a support for heat waves impact studies. And how? Through hazard assessment. Specifically, the hazard assessment has been providing by considering the specific index, humidex index, and starting from an ensemble of Eurocordex climate simulations, and consider different IPCC scenario. Moreover, the data of the different simulation was corrected by using a specific bias correction. The add value of this tool is the possibility for users to use several bias correction according to your needs. Finally, the climate results performed by Clime service has been used for further impact studies, for heat waves impact study, and Clime service has been proved to be a useful tool to integrate climate change in the planning, in the process planning, and to improve the making process. So, what are the main goals of this service? The main goal of this service is to support the users, different users with different expertise, and also to improve the understanding of climate impact through different solutions, different indicators, different data. Because Clime as a climate service should provide climate information, climate analysis in order to help different users to make climate smart decision. Moreover, Clime service should provide, should meet the needs of users, and should be based on exchange between users and providers of this service. So, in conclusion, the next steps are the update of the solution product based on not only on research activity of REMI division of CMCC, but also based on requirement provided by different users that can be not only researcher but also consultancy company, local authority, private firms. And among the next challenges, there are the integration of these prototype service prototype with the sectoral services, and so the integration of new variable, new data, in order to extend the scope of this application. So I invite you to explore the prototype web platform under development, and thank you for attention. So I leave the floor to Harilaos. Harilaos? Okay.
Hello, everybody. I'm here. Let me jump in directly into the presentation. And the presentation about the decadal projections, decadal forecast that we have developed for within the CLARA project. Allow me briefly to describe who we are. We are a commercial climate data provider, and our positioning is to help other providers by support them with data management and data processing. So we're in between the data producers, let's say, and the various consultancies and adaptation professionals that deal with the decision makers. So basically what we do is to make the data ready to use, and by ready to use we mean by processing, doing various processing steps between the raw data and the actionable data. It's quite technical. It's between remapping, sampling, formatting the data, merging files, calibration of the data, downscaling, and quality control. It's basically all the tedious work that everybody has to do before being actually able to use the data for their application. So what we have done, and which is our first product so far, is we have made available 6 surface variables and 40 indicators. Surface variables are the 3 temperatures, daily average, mean and max, solar radiation, surface wind, and others. And this is downscaled at 0.5 degrees, all daily values, all the same IP5 models for the 2 RCPs. And we have pre-extracted all the data at city level as time series, and for 100 countries as 2D files. And our main purpose in terms of user experience was to give easy access to the data. So we have created a simple platform, which is basically a search bar, where you only look for the data that you need. There is no visualization. You just access the platform, and in 2 clicks, you have access to the data and download it. It's up to you afterwards to exploit the data as you want to exploit it, either for research or consultancy. And we work with adaptation professionals around the world. Since we started the service 18 months ago, we have over 700 registered users that downloaded data, and mostly from developing countries, but also from countries under development. We are working on higher resolution projections for next year. They will be based on ERA 5 and ERA 5 land. And since they are reanalysis, we can have any variable that we want. And the downscaling would be global at 35 kilometers and at 9 kilometers for Europe. And we'll have access to daily values covering 1950 to 2100. And again, all the CMEC5 models and the 2 RCP scenarios. After the projections, as new product development, we're developing also the forecast. So presently, we are providing the projections, but we're also going to provide sub-seasonal and seasonal forecast, and the decadal forecast, which has been the goal in CLARA to develop this service about decadal forecast. So let me now address the second part of the presentation, which is specific to the service that was developed within CLARA. The motivation was that the adaptation practitioners that are essentially the majority of our user base could benefit and want to benefit from the decadal forecast. That's from the user point of view. In technical terms also, decadal forecast has the similar issues as any other model product, which basically we can say that it's not directly usable and needs calibration as well and other post-processing. So during the project, we evaluated the user needs in terms of decadal forecast and tested a new calibration technique. The setup was quite simple. We used one model, Handcast. Handcast is a historical forecast, let's say, from the French Research Institute Pierre-Simon Laplace. And we calibrated with a new method called CDFT. I won't go into the details of the calibration method. Free to contact me afterwards if you want to know more. And we engage with adaptation consultants, firstly our user base, but also other consultants we are in touch with. And we also engage with the decadal forecast scientific community. Simple background about the decadal forecast. Here on this graphic that you can see is in black line the historical observations, and the various colored dots are decadal projections over time. This is what we call the Handcast. So we put ourselves in the 60s, 70s, and 80s, and we start a forecast for the next 10 years. And you can see with the color codes the result of this forecast. So this graph shows typically how the forecast should look like. The problem is that the raw forecast actually looks like this. The forecast has to be calibrated, has to be statistically processed, because model and reality have some gaps, and the state of the model is not the state of the actual observations. So just to make it short, all the processing is done there to make the raw forecast look more realistic and to make the adjusted forecast. To give you an idea about the skill of decadal forecast, we can have a parallel between the decadal and seasonal forecast that maybe some of you are more familiar with. In this graph, we have the decadal parallel between decadal and seasonal for precipitation and temperature. The forecast horizon for decadal is the average multi-year, so the average of year 3 to 5, looking ahead, and the seasonal, the average of month 2 to 4, looking ahead. And we can see that we have similar types of skill here in terms of correlations. So we are in something that is quite similar in terms of skill regarding the different scales. We have to say here that part of the skill comes actually from the fact that we see a warming trend. So the skill is good because also we have a warming trend. If you take out the warming trend that we are observing because of climate change, the skill is a little bit less. Precipitation also has, there is some skill in precipitation. It's lower and it varies regionally as it is for the seasonal forecast. So there is skill to exploit there. What we learned during the projects in terms of scientific issues is that our method works, which was a good news, and it allows the daily adjustment of the data, because so far the adjustment of the data was done either at yearly or monthly scale, and we adjusted the data now at daily scale with obtaining similar skill. In terms of forecast quality, there were many issues in terms of metrics, how to express the focus quality for the user. And there we have similar open questions and issues as for the seasonal forecast, how to adapt the metrics of quality according to user needs. So in terms of communication, we need to define a consistent terminology and well-defined and don't speak only for us, I mean for the whole seasonal and decadal community, to have a terminology that is that makes sense for the users. Another issue is that the forecasts are quite uncertain. It is probabilistic forecast as for the seasonal, and users still have issues in dealing with probabilistic forecast. And I left the most important for the end. There is a need for a multimodal ensemble approach. That means no decadal forecast model made by various institutions has enough skill to be used by its own. There needs to be an effort from the community to put all the decadal forecast model together and produce a multimodal forecast, so to be able to extract significant skill for the users. What we learned from the users, and first with the adaptation practitioners, is that they are reluctant to use averages over several years. They want to have more precise information. They want to have an information for the following year or the year after. So not keen on having multi-year averages. They also request higher resolution, and the resolution presently is in terms of hundreds of kilometers, not tens. So there is a demand from the user side to downscale what is available to a higher resolution. And the uncertainty of the decadal forecast remains unusual. They find the forecast quite uncertain and difficult to use. So during the project, we could see that the adaptation practitioners were not ready to use the service as it is now presented. And we turned our interest to a new type of users, which is the scientists themselves that are interested in the daily adjusted forecast. As a conclusion, I would like to bring some good news for the in terms of the decadal forecast, is that there has been over the last couple of years, and this is very recent, this is a paper that came up early this year, announcing an effort from the community to move towards operational predictions of decadal forecast. This is an effort also to put together the multimodal forecast I was talking to you about. And this also translates in terms of products developed by Copernicus Climate Change Service, because they recently had a call to set up a prototype service for decadal climate predictions. So there is a strong trend in the community in moving from research type decadal predictions to operational decadal predictions as it's done for a seasonal forecast. Thank you for your attention. Are we addressing questions now?
So, thank you. Thank you both. So, I don't see any question in the dedicated space here on your webinar tool. So I would like to ask a couple of questions to our presenters. So I'd like to ask a question to Giuliana first. So my question is, can you tell us what kind of format you release your data, and what's the resolution that we can expect from your Clime service?
Okay, thank you. So concerning the Clime results are available in different formats that can be shapefile, maps, plots, and report in the case the users, for example, to ask the development of local climate profile. So this output can be used for different users with the skill in the program skill on the, or users with can use a plot or graph for in order to integrate these results in their activity. And this output can be readable by other software, for example, GIC software, and it's okay.
Okay, thank you very much. And just one other thing, because you said something very interesting, in my opinion, that there is the possibility to release also a report. So it's not just data what you provide, but you also provide a report which is customized on the user's need, right?
Yes, it is important because the user can use a report for other activities, and for example, if users can use software or not expert in the climate change, in climate analysis, you can use this report or plot in your activity.
Great. Thank you very much. I have a question for Harilaos, but I will wait because we have a question coming from our public, from Alessio Capriolo, who asks, will Clime service downloads be free of charge? Or, people will be paid for that? Giuliana, is for you, huh? Talking about the Clime service.
So in our case, Clime available, the web prototype service is available, and at the moment we must close some factors about commercial aspects, and so in the future the results, the output of this service can be provided different users as commercial products.
Okay, thank you very much. Thanks a lot. So while we wait for other questions from our public, please don't be shy. You can type your question on the dedicated space in your webinar control panel tool. I would like to ask a question to Harilaos. So my question is, so basically you are a little bit in between, as you said, between the science world and the user world. So you basically are a little bit pulled from both sides, you know, like there are scientists who say, no, you cannot provide, you know, any results in terms of, for example, of annual means, but you need to provide, you know, like multi-annual means for the decadal prediction to be actually consistent and reliable. And on the other side, you have users that say, no, we don't need like this kind of aggregation because 4 or 5 years is too much. So we need yearly outputs. But scientists know that yearly output on a decadal time scale is not something that is actually, you know, like reliable. So how can you mediate? How can you find a compromise between these two worlds?
Well, as you said, we're in between, but as I presented, we are not dealing with the final stakeholder, the one that has to make the actual decision. We're here to support either other providers with the data. So who are actually in front of the user, in front of their client, and need to produce something. So for the example you just said, is actually what we told our providers, that the skill is not good enough for annual forecast, and we have to wait a little bit more for the skill to get better, or to imagine other type of statistics that could be based on multi-year averages. So we're still constructing a little bit the way to present the data, so to have, you know, information that is scientifically sound, but also usable by the consultants to present to their clients. So we're not there yet. It seems that it's not really mature. That's why I said that now, as you know, as clients and finally the users that are using our adjusted decadal predictions are more scientists, and we're working with more and more with scientists that want to explore this type of data.
Interesting. Thanks very much, Harilaos. So I think like for the moment, we have no more questions. So I would like to remind everybody that it is possible, in case you're interested, to contact our webinar people through the email address webinar@cmcc.it, where you can send emails even after the end of this webinar. So if there are no more questions, I would like to say goodbye to everybody. I'd like to remind you that the next CMCC webinar will be next week on December 19th, next Thursday at 12:30. And the title is Urban Flood Modeling in a Changing Climate. And the speaker is from CMCC, Roberta Padulano, and the moderator is also from CMCC, Materia. So we have a last minute comment. It's not a question. Sandra Spillane said thank you all, that she found like your explanation very interesting, and she's thanking our presenters. So we all thank our presenters, because it was a very interesting session today. And I would like to say goodbye to everybody and see you to the next webinar series. Goodbye.
Bye-bye.
Bye. Bye-bye.